So in part 3 of our 14-part series on relations and functions, we are looking at demonstrating an understanding of the effects of horizontal and vertical stretches on the graphs of functions and their related equations. So this is going to be another example of transformations. So we talked, last time we had an example of taking some shape and translating it left or right. We're going to be stretching them. So not just having this, but say something like this. Stretching it to the right, but leaving it unchanged up and down. So this is the next type of work that we're going to be doing. This one also has a counterintuitive aspect. So just like translating to the right, we were subtracting instead of adding. Here, if we want to stretch it and make it twice as wide as it used to, actually it looks more like 3 times, so we'll use the number 3 instead. We don't replace x with 3x, we replace it with 1/3 x. Why? Because the y value that we used to have when x equals 3 is now the value we have when x equals 9. But to get that function to spit out that value, the argument here has to have the same value that it had when x equals 3. So this 1/3 x equals 3, or x equals 9. So we have to reciprocate that term before we multiply the x by it. Similarly, if we want to stretch in the y direction, if we want to stretch up and down, well, there we'd have a 1/b if we're stretching by a factor of b. And again, we get some confusion. It seems like we're doing different things for x and y, because x we always write the transformation term immediately next to the variable, whereas with y, we have a habit of keeping y isolated and multiplying it over to the other side. So instead of being reciprocated, it is as it normally is, because it is not directly attached to that variable. It has been moved to the other side of the equation. So these are the basic fundamentals of vertical and horizontal stretches.